Good afternoon, everyone. Dear authors and invited guests, welcome to the technical session 12A. Myself, Siddhi Avdi, and I'll be a session moderator for today's virtual conference. On behalf of the Global Knowledge Research Foundation and GR Scholastics, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD. This event, the 10th edition of the conference, is being held in an hybrid mode. The physical event was held in Goa, and the virtual event is being held via Zoom meeting from 17 to 19. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we will be having in total 10 presentations. Each presenter will be given a time span of 8 minutes for the presentation and 2 minutes for Q&A. I will be raising a gentle reminders at 7 after 7 minutes. There is also another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, just before we get started, I would like to introduce you all to today's session chair, Dr. Vidya Gaikwad. Dr. Vidya Gaikwad is an associate professor at Vishwakarma Institute of Information Technology in Pune, boasts over 14 years of experience in academia. She demonstrates a commitment to advancing her knowledge and contributing to cloud IoT security. Her dedication to academia is evident through her active involvement in organizing numerous national and international conferences and her prolific publication record. Welcome, ma'am. Welcome to today's session.
Thank you, Siddhi, for a wonderful introduction. So we can now we can start with the session. Yeah, right. Thank you. Yeah.
Without any further ado, let's get started with the session. So the very first presenter we have here today, it's Nehal Balasaheb Salve from Pimpri Chinchwad College of Engineering, and the paper title is A GAN Approach for Energy Consumption Forecasting in Built Environments. I request Nehal ma'am to please start with your presentation. If any of the co-authors are present, they can also do the presentation on her behalf. But I think she's not there in the meeting. We will just go ahead with next participant. So the next participant is G. Rupa from Sir M. Visvesvaraya Institute of Technology. And the paper title is An Adaptive Fault Tolerance and Control Strategy Techniques for Power Electronic Traction Transformer, PETT. Ma'am, if you're there in the meeting, please start with your presentation.
Yeah, thank you, ma'am.
You can share your screen now.
Yeah, ma'am. I hope my screen is visible, ma'am.
Yes, ma'am, it is visible.
Yes, ma'am. Yeah, it's visible. Yeah.
Thank you. Thank you for joining me today. Myself, G. Rupa, Assistant Professor, AIT Bangalore, and my co-author is Dr. H.L. Suresh, Professor and HOD, Triple Department, Sir MVIT Bangalore. Today, I am excited to share insights of my research paper on adaptive fault tolerant and control strategy techniques for power electronic traction transformer. And my paper ID is 68. And these are the contents that I'm going to present today. Introduction, problem statement, literature survey, research gap, objectives, methodology, results, conclusions, and reference. And coming to introduction, power electronic traction transformers, in short, they are called as PETs. They are critical components in modern power systems. With the large scale and rapid development of high-speed railway all over the world, energy saving and lightweight design of high-speed train has become an important research direction in the field of traction drive system. PET is a new traction drive system which can reduce the energy consumption and weight by replacing the traditional transformers, which are of larger volume, heavy weight, and low efficiency. The use of medium frequency transformer in power electronic traction transformer reduces weight and increase energy efficiency. This is particularly beneficial in electrical trains. Despite of their benefits, pets face challenges in dependability due to inherent defects. These defects can degrade the system performance, or it may cause a catastrophic failure. This PET is a two-stage converter with cascade H bridge in the first stage and dual active bridge in the second stage. This PET consists of n submodules. If one of the submodule fails, the whole traction drive system runs into fault condition. Therefore, there is a demand for fault tolerance strategies to ensure reliable and stable operation. Coming to problem statement, a proper fault tolerant method is needed to remove the fault and recover the systems from the fault. If the process of fault tolerant method is too complex and costs a long time, the system may run into unstable condition, or it may bring larger impacts on voltages and current. Therefore, it is very important for PET to choose a correct fault tolerant method for smoother operation. And these are the three fault tolerant methods that are called as traditional methods. There are some common issues with the traditional methods. In the first method, that is in increasing power, during normal operation, each submodule is put into the operation. When the fault happens, it cuts the fault module and increases the power of the rest of the submodules. That means it keeps the DC voltage to be same before and after the fault, but it needs to modify some control parameters such as reference voltages, phase shift angles of the CHP modulation, and DAB pulses. And second method is increasing voltage. Increase of DC voltage of each submodule, utilization of voltage is higher, and the medium frequency transformer will not make adjustment to input and output voltages. Even this method also have some complex fault removal of the process and cannot realize the smooth operation. And coming to backup method, when the fault happens, it bypasses the fault module. It is also not suitable for PET, as the bypass process of the backup submodule will lead to the zero capacitance of the zero voltage of DC voltage, this capacitance. Zero voltage of DC capacitance of CHP. Therefore, additional charge process for the CHP is needed, and power balances are still needed to be considered when the fault happens. And moving on to the next slide. A total of 60 papers were reviewed, and out of which 20 papers have been included. And here I am explaining only 5 papers. In the first paper, various topologies have been considered for the realization of PET for traction applications. And in this paper, the topology is implemented using thyristors, and the use of thyristor limit the MFT frequency to few hertz or of very few hundreds of hertz. And in the second paper, the author suggested that CHP and DAB converters, when incorporated into the power system, they pose the possibility of improving the general performance of the system as well as its resilience to faults. And in the third paper, research has aimed at applying the modern machine language algorithms such as space vector machines. SVMs in the classification of DC to DC fault diagnosis has reached the accuracy of 95%. And in the fourth paper, specific fault control strategies have been discussed in this paper to improve the fault tolerance of CHP converter. This approaches ensures that constant conversion operation even if one of the submodules are faulty. And in the fifth paper, according to this survey, machine learning algorithms in PET systems take a shorter time to identify the faults and prevent it from further damage. Coming to the research gap, the literature survey reveals that existing survey on the PET mainly focuses on the traditional methods. That means only some researchers have addressed power switch faults, power switch fault diagnosis for inverters and converters. Only a little effort has been undertaken on the analysis of issues of fault detection and fault characteristics. So far, a little research has been considered carried out for the protection of PETs based on the reverse charging. Therefore, in the present work, an improved fault tolerant method based on reverse charging is proposed. And coming to the objectives, the objective of my research work is to improve the fault tolerant method based on the backup method is put forward. Improved fault tolerant method to provide the reliability of the PET is adopted, and the improved fault tolerant method based on the reverse charging control is implemented using future extraction and machine learning algorithms. And the problems faced by the traditional methods such as waveform distortion, CHP DC voltage, that means no CHP DC voltage, and unbalanced power is mitigated with this approach. And coming to the methodology, This, as I said earlier, the PET is a two-stage converter with cascade H bridge in the first stage and dual active bridge in the second stage. It consists of n sub-modules. In the proposed module, this n plus 1 module operates as a redundant module. That means module 1 to n operate normally and the module n plus 1 operates as a redundant module. Here, a pair of IGBTs, these IGBTs in the module n plus 1 of the CHP keep conducting to bypass this module n plus 1, which can make the fault removal of the process smoother. At the same time, DAB of this n plus 1 charges the DC capacitance in the reversely and keep the voltage same as that of the other submodules even if the fault occurs. Some core algorithm, machine algorithms such as support vector method, support vector machines are pivotal in this fault detection. This approach demonstrates raw.
Ma'am,
Yes, ma'am.
ma'am, sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Okay. And these are the results. If you can see, the using improved fault tolerant method, the fault is reduced compared to this increasing power and increasing voltage method. And these are the parameters that we have used. And these are the results. The detection accuracy is more than 98% with this improved fault tolerant method. And whereas the traditional method it is 85 to 92%. And the localization time is also very less in the improved proposed method. And these are the conclusions. So in this work, I have used an advanced control strategy for PET for enhancing the fault detection accuracy and localization speed. The use of machine learning algorithm with the reverse charging control ensures the stable operation and reduced cost. So the integration of advanced techniques aims to enhance the system resilience and performance. So this contributes to the overall efficiency and reliability of power electronic systems. And these are the references that I followed in my work. Total 20 are there. Thank you so much.
Yeah, very good presentation, ma'am. Great
Thank you.
efforts for your research.
Thank you.
Yeah, one question from my side.
Ma'am.
How is this galvanic isolation is maintained in PETT?
Ma'am, whenever the fault occurs, automatically it will bypass the that fault module and it is replaced with the M plus 1 module, ma'am.
Yeah. Okay. Thank you, ma'am. Yeah.
Thank you so much.
Yeah.
Can I leave, ma'am?
Thank you, ma'am, for your presentation.
Thank you.
All the participants are expected to wait till the closing remarks. We have a few instructions to convey.
Oh, thank you.
So the next participant is Sanskar Raut from Vishwakarma Institute of Technology. And the paper title he's presenting on is Auto Hub Integrated Vehicle Washing and Expense Management with AI and Blockchain. I request Sanskar sir to please start with your presentation.
Am I audible, ma'am? Hello?
Yeah, you are
Yes,
audible. Yeah, you are audible. Yeah.
Okay. So is my screen visible, ma'am?
Yeah, it's
Yes.
visible. Yeah.
Okay. Greetings to everyone. My name is Sanskar Raut and I am a student from Department of Computer Engineering at Vishwakarma Institute of Technology, Pune. I am here today to present our group project Auto Hub. My team members are Rohit Rathod, Sakshi Rathod and Anisha Sudhanshu. Our project was completed under our guide faculty, Professor Santushti Bedgiri. So let me hide this. So AutoHub is our integrated platform which is designed to simplify vehicle washing and expense management. These are the contents that I will include in my PPT. So as the overview states, AutoHub is our integrated platform designed to solve the challenges of the fragmented automotive services market by unifying all the essential vehicle services. In this presentation, we will walk you through our entire project journey. First, we will start with our problem statement. I'm sorry, ma'am. Then our solution, our core features, methodology, and the future scope. So, right now, the way we manage our cars is completely fragmented. We have to use different apps, different websites, and local garages for everything from a simple car wash to major repairs. This creates a very real and everyday problems. We all know how inconvenient is it to schedule in the service and waiting in the long lines. When we looked at this whole picture, the main issue became clear. There is no single all-in-one platform that brings these essential services together to make the life easier for the car owners. This market gap is precise opportunity that AutoHub addresses. So next is our solution. To solve the problem of the fragmentation and inconvenience, we developed our solution AutoHub. AutoHub is a single integrated platform that acts as an all-in-one app for our car. At its core, our platform streamlines all the difficult tasks. It brings everything like booking a car wash, tracking your expense, and managing your important documents together in a one simple application. We have made it accessible to everyone with a user-friendly Android app and a web application. Ultimately, our mission is very simple to make the owning of the car easier and less stressful for everyone. So this is what our application Auto offers. First one is flexible service booking. User aren't just logged into one option. They can choose various options like doorstep, pickup and return, and a traditional appointment booking. Also, the next feature that we have integrated in our app is vehicle expense manager. There is no vehicle expense manager in the market right now, so we have integrated that feature in our application, which makes our application to easily track all the vehicle related cost and maintenance, and also the tools for the better financial decisions. The third feature was document manager. It securely stores the vehicle documents in an automatic reminders along with the automatic reminders and expirations. We have used Firebase for saving those documents as a cloud storage. Next one was AI powered analytics. With the help of our AI, we can basically predict the future cost as well as we can help the users to maintain their maintenance spending. There is also in-app chat support, which allows the user to get a quick answer to their questions and assistance with bookings. Finally, our owner dashboard is basically give the service owners a different UI for their business performances. Next is methodology. So this is basically the complete flowchart of our overall structure and the service flow of the Auto platform. Let me quickly walk you through it. So AutoHub is basically built of the three main pillars: expense manager, document manager, and our core automobile washing services. On the left, it is expense manager, which allows user to track all the vehicle related costs. We have created clear categories like tolls and fines, maintenance, fuel, and other miscellaneous costs. The user can also add different categories on their need. Next is document manager. Document manager act as a secure digital wallet for important documents like RC book, insurance, driving license. The key feature here is automatic expiration alerts, which notifies the user for their document expirations. And the third one is our core automobile washing services. Let me hide this from here. The third one is the automobile washing services. This is not just a simple booking system. It includes secure payment, which has been possible using the Razor Pay. Next one was vehicle location tracking. Third one was in-app support, and the services that this offers are pickup and return, appointment booking, and doorstep car washing. So the next, this is how our project UI looks like in the application. So finally, let's talk about our vision for the AutoHub. Firstly, we plan to connect our app to the car's internal computer, basically the OBD port, because every car has a OBD port. And with the help of an OBD scanner, we can connect our mobile devices with the car and can track their real-time health, like the mileage, the fuel usage, as well as the car's engine and battery health, which will help us in maintenance of the car. We will also try to use advanced AI, which will help us to predict when a part might need attention before it breaks, and it will also help to give personalized suggestion to the users and also help in the saving money. Third one is about enhancing the trust with blockchain. we can integrate the blockchain technology to create a secure, tamper-proof, and verifiable service history, which will help our future buyer to ensure the trust and make the system completely transparent. And lastly, just a minute. And lastly, we plan to expand our entire service ecosystem. We will add new on-demand services like interior detailing and create a marketplace for spare part and roadside assistance, making the Auto Hub a true one-stop solution for all the car needs. So these are few of the research papers we have had, which have been the major part in research. So thank you. This was all from my side.
Yeah, good efforts. Can you let me how you're maintaining the security of the users on your Firebase cloud? Which algorithm you're using for maintaining the security?
Basically, a Firebase has its own protocols, so we don't have to put much efforts in the security of the task. We will just fetch the data from the Firebase and show it to the users.
Okay. Okay, fine. Thank you. Yeah.
Thank you, ma'am.
Thank you for your presentation. Now we will move on to the next presenter. The next presenter is Pratik Nagre from Pimpri Chinchwad College of Engineering, and the paper title is Brain Tumor Segmentation and Prognostication. Sir, please start with your presentation.
Hello everyone. Am I audible?
Yes.
Just is my screen visible?
Yes, sir.
Okay. So good afternoon everyone. My name is Pratik Nagre and I am from Pimpri Chinchwad College of Engineering, Pune. And I am here to talk about my research paper topic, which is brain tumor segmentation and prognostication. Let's start with the introduction. Brain tumor is a growth of abnormal cells in the brain. As we all know, it can be cancerous or non-cancerous, but both can cause serious problems. One common type of brain tumor is called glioma. Our project is mainly focused on this type of brain tumor, which is a glioma. These are divided into low-grade and high-grade types. The most dangerous form is glioblastoma, which spreads fast and is very hard to treat, and it's very aggressive in nature. So basically, detecting and analyzing these tumors is a very big challenge. Right now, various radiologists and oncologists often have to manually go through MRI scans to find out and mark tumor areas. This process takes a lot of time, and results maybe vary from one doctor to another, which can lead to mistakes in diagnosis. And another major challenge is predicting how long a patient might survive after being diagnosed. This depends on many things like the size and type of a tumor, and also the patient's age or the treatment he is receiving. So basically, in our project, we try to solve both problems. We built a deep learning system that uses 3D unit to automatically find tumor areas in MRI scans, basically 3D MRI scans. Then we use features from these scans along with patients' data to predict survival time using machine learning. So let's move on to the next part, the literature survey. In our literature survey, we studied several research papers where different teams tried various segmentation algorithms like UNet architecture, VNet, attention unit, ResNet, etc. for brain tumor detection. Each of these models use different performance matrices, and also they have tried a variety of different loss functions to evaluate their results and to improve their accuracy. While some achieved a good accuracy for tumor segmentation, while others struggle with accuracy part, especially in the survival prediction part. What sets our project apart is that we combined both radiomics features and deep learning features. Basically, radiomics features, in short, is a feature extraction technique specially used in medical problem statements. These features are quantitative measurements extracted from medical images using mathematical algorithms. With the help of these features and deep learning features from a 3D unit model, and by combining all of them and by applying machine learning algorithm, we are managed to achieve higher accuracy than others. So let's move on to our next part, which is a data set. Basically, our data set is divided into three parts: training, validation, and testing. The training data set include the MRI scans of 369 patients, with each scan set containing four MRI sequences, as mentioned: T1, T1C, T2, and FLAIR. And the fifth one is the segmented mask, which is an output for our segmentation part. In that segmentation mask, there are four parts: edema, necrosis, enhanced tumor, and non-enhanced tumor. Uh, the next, the validation data set had 125 cases, and also the testing data set consisted of 166 cases. So let's move on to our basically our project is divided into three main modules. So our first module is tumor segmentation. Whatever the data set we have got, we have applied some pre-processing techniques like scaling, normalization, data augmentation techniques like resampling, cropping. Uh, after pre-processing all our MRI scans, we have passed it as an input data to our 3D unit architecture, with the variety of performance matrices, and we chose the most suitable loss function for our model, and we train our model for around 1000 epochs. After all this, we managed to get our mean intersection over union as a 86%. In normal machine learning problems, we consider as a accuracy, but in medical problem statements, we consider here mean intersection over union. It's basically mean IOU. In the right hand side, as you can see, there is an sample image of MRI scans, and the fourth one is a segmented output. This one, as you can see, this dark blue part is nothing but it shows dead cells of that area. Surrounded yellowish part is nothing but a swallowing part of that brain area, and the last one green part is nothing but a actively growing cells, tumor cancerous cells in that area. So the next one is this 3D unit architecture we have used for segmentation part. It's basically a U-shaped architecture, as you can see. The here left side is an encoder part, below is a bottleneck layer, and the right side is a decoder part. This encoder part is nothing but an down is consisted of a downsampling layers. Whatever the input MRI we pass here, with the help of this encoder part, it extracted all the important features of MRI scans through here bottleneck layer, and by extracting all the important features, we again reconvert back our MRI scans to its original shape. So here this downsampling, upsampling layer is useful here, and with the help of these skip connections. So next one is modules. As I have already explained the first module, which is segmentation part. The second one is a feature extraction. In feature extraction, as I have already told that we have used both radiomics feature and deep learning features. With the help of this feature extraction, we managed to get 1200 to 1300 features for each patient's MRI. So with the help of all this, we have converted it into Excel data, and whatever the another Excel clinical data we got from our data set, in which there is a patient's age and number of survival days they have given. By combining all these features and clinical data into one Excel file, we have applied some feature selection technique, as at a time for each patient 1200 to 1300 features passing through our machine learning model is not possible, and it may lead to overfitting. So that's why we have, by applying some feature selection techniques like PCA, we have selected some top 50 features, and we have passed these features to our machine learning models. Here we have used decision tree with the help of hyperparameter tuning, to get a higher accuracy for our survival prediction model with the help of this classification technique. So at the survival prediction part, we managed to achieve an accuracy of around 97%. Further, there are algorithmic details. The first one is the unit architecture, and as I have already explained this, the second one is decision tree. The decision tree, as we all know, is a supervised learning algorithm that predicts patient survival categories. As you can say, here is a short term, intermediate, and long term. In the survival prediction part, instead of showing direct the exact number of
Hello.
survival, hello, yes,
So sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
okay, okay, sure. So as you can see, these are the results of our work. This one is the segmented output, and this one is the survival predictions classification report. And these are the graphs for accuracy and loss of our segmentation part. These are the sample output. We have created one website for this, and here we comes to the conclusion as a complete system for brain tumor segmentation and survival prediction, with a 3D unit chosen as our final architecture after comparing multiple deep learning models. The survival prediction model achieved around 98% accuracy in classifying patients into short, medium, and long-term survival categories. These are the overall references of the research papers we have referred. Thank you.
Yeah, can you interpret some of the false positives and false negatives which are present in tumor segmentations?
Like in our project or in general case?
Yeah, in general case.
Yeah, in general case, as we know that this glioblastoma is considered as a grade 4 level tumor.
Mm-hmm.
So finding out through various radiologists and oncologists are working on it. So finding out through with our naked eyes, like we see MRI scans. So we can't find exactly the region area, we can say, like what's the particular region of swallowing, what's the particular region where cells are already brain cells are already dead. We can't find that through our naked eyes. So here what our algorithm or project helps our radiologist or oncologist.
Okay, thank you. Yeah, thank you.
Welcome.
The next presenter is Shubhadeep Saha from SRM Institute of Science and Technology, and the paper title is Degradation Agnostic Medicine Strip Data Enhancement via Residual Learning. Sir, I request you to please start with your presentation.
Yeah, am I audible?
Yes.
Okay, so I'll share my screen now, right? And start my presentation. So, is it visible to all?
Yeah, it's visible. Continue, sir.
Yeah.
Continue.
So, greetings everyone. My name is Shubhadeep Saha, and I graduated from SRM Institute of Science and Technology. And with the help of our professor Vaishnavi Murthy and Jagadishan Murthy, along with the co-partner Anshuman Kumar, we have developed this project called Degradation Agnostic Medicine Strip Data Enhancement via Residual Learning. So, let's understand what we are actually doing. So first, let's go over what denoising is. So denoising means removing the unwanted visual distortion from an image, right, to extract the important features, right? So talking in context to our project, denoising would basically means removing the unwanted noises from the medicine strip data over a specific sensitive information, for example, the expiry date, such that it can be easily readable by human or extracted by an OCR system. So understanding the problem statement like this, for example, if you are in an emergency and if you want to consume a particular medicine, right, so you would want to look over the expiry date to see if the medicine expired or not. But in certain cases, over maybe because of various reasons such as inaccurate printing or smudges due to ink blot system, or maybe because of environmental degradation, the expiry date may not be visible. Since expiry date is a very sensitive information, to consume something as sensitive as a medicine will indirectly harm the health of the consumer. So to have proper clarity over the expiry date. For example, if it is June or July, both of them are very similar. If it is 2024 or 2025, these critical informations are very important before we consume the medicine. So our project was mainly based or developed around how we can accurately extract this expiry date and remove the noises from the medicine image. So, introducing our model, what we are going to do is we have collected our data set. It's our noble data set. We have collected from various distributors. We have collected around 350 images, and over the images, we have applied degradation, artificial synthetic degradation, because we cannot find the images. One of the main constraint is we cannot find the data set which has improper or partially visible expiry date. So we need to consider all the possibilities. So this brings us to the first stage of our methodology. We want to mimic the real world degradations. For that, we have augmented various kind of noises, for example, Gaussian noise, Gaussian noise, salt and pepper noise, artifact compressions, for among which the salt and pepper noise and the Gaussian noise are the most important. We have selected random images from the dataset and assigned a random voice in random ratios. So this makes what we are going to do further more generalized. So in the stage 2, we have implemented the denoising convolution neural network. Now there are various other neural network models such as denoising autoencoders, which reduces the image to the low dimensional latent form, and then from the compressed image, it starts to learn the important features. But again, it produces inaccuracies and blurry outputs. Previously, more handcrafted models were used before the neural network came into play. For example, block matching 3Ds, where they basically collected various pixels, stacked it into a three-dimensional structure, which gave it a context and performed DCTs or wavelet transformations on that. But again, it was not a neural network model, and it did not learn from the data. So we could not take in consideration BM3D, and we could take in consideration either DNCNN or denoising autoencoders. DNCNN provides the best output because of the residual learning. Just like we saw in our title, residual learning, that's exactly what it does. It learns the noises. Instead of constructing from the noisy input to the denoised input, it basically learns the noise. It learns the noise from the noisy image. If we subtract the noise, we get the original image back. So that is the main uh, algorithm that we are going to use in our model. So after we have done the successful synthetic augmentation, right, various Gaussian noise, Poisson noise, etc., we are going to pass this data set into our model, denoising convolution neural network, which contains 17 convolution neural networks. The input layer is the noise augmentation, which characteristics normalized between 0 and 1. Then we start the 2D convolution layers, each containing 64 filters and 3x3 kernels with rectilinear linear unit activations. Right, so 3x3 is kept to keep the local context small and efficient. Right, after that, we move on to the last layer. Now the last layer is one filter 3x3 linear output, because we need to take in consideration the negative and the positive values as well. One thing to note here is we do not include any dropout layers, because we do not want to randomly remove the important features that is needed to be learned, right? So the training configuration is 70, 20, and 10, and we use Adam optimizers with the learning rate of 0.0002 and beta of 0.9 and beta 2 of 0.999. Epochs we have kept of 20 and batch size of 4. And now when we are talking about after successfully implementing the model, when we are talking about the validation, we're not talking in terms of just accuracies, right? AUCs or ACCs. We talk about SSIM and PSNR when we are dealing with the denoising experimentations, right? So for noise function, we have used mean square error. After that, these are the results that we have got. The PSNR overtraining, as we can see, is for various types of noise level. At Gaussian 15, we have Gaussian 25 and Gaussian 50. So PSNR is 26.2 and 24.8 and 22.7. It is quite natural that PSNR will reduce for the higher noise levels, but we have achieved the standard noise level of 26.2 and SSIM of 0.8. Right. So after this, let's move on to, yeah. So this was our model till date. Now we have done certain further, we have taken consideration of certain further aspects, like what can we do after we have successfully achieved the denoised image. What we can do is we can we can perform certain OCR based experimentations on it that we actually did. We use text localizations, and after that we have achieved an extracted output, which I will show here. Now, after denoising, which we have got the particular output, we are going to perform certain OCR experimentations. Now we have used easy OCR, which was trained on ICDR, and we further use the same pre-trained model to extract the expiry dates, and we can see this is what the main difference is. For noisy image, it shows an average confidence score, for example, 68.4. This is an average for noisy image, and for denoised image, it significantly increased by over 15 to 20%. It is 81.7. So that's how much denoising convolution neural network helps in denoising the expiry date data. So this is the output, and finally, what we have done in our project is implementing the OCR model as well as the denoising convolutional neural networks to achieve something which would help in the medical industry, right? The target consumers are either the local consumers like us, or say the medical practitioners. Even, for example, a pharmacist can be the consumer, or maybe the nurse can be the consumer. So this is our project for now. For future development, we are thinking of, since we have already used the OCR based system, we are thinking about providing certain visual or audio based augmentation for better clarity. So thank you everyone. This is my presentation. I'm open to any kind of questions.
Yeah, can you tell me some ethical and clinical implications which are applied for denoising models in medical imaging?
I didn't get you. What considerations?
Yeah, can you list out some ethical and clinical implications which we can apply for denoising model in medical images?
In medical images, actually we are dealing with more pharmaceutical based images and not just medical industry. For medical industry, we can do more about, such as certain ECG records, or maybe the fine gentleman who presented about tumors, we can denoise them. But we are focusing more on the pharmaceutical strip data, like the backside of the medicine. So for that, the ethical
Yeah.
implementations could be like the removing the false confidences, or the patient safety, or removing such biases in the data set, like that.
Okay, okay. Thank you. Yeah.
Yeah.
Thank you, sir, for your presentation. Now we will move forward to the next presenter. So the next presenter is Shweta Kumar from MIT University, and the paper title is Fast Healthcare Interoperability Resources in Healthcare Sector for Transformation-Based Futuristic and Narrative Approach. Ma'am, please start with your presentation.
Hello, am I audible?
Yes.
Yeah. Myself, Shweta Kumar, and I'm here to present my paper. Let me just share my screen with you all. Uh, Is my PPT visible?
Yes, ma'am.
Hello? Yes. Okay. Myself, Shweta Kumar, and I'm here to present my presentation on fast healthcare interoperability resources in healthcare sector for transformation-based futuristic and narrative approach. My co-authors are Dr. Sarudhir and Dr. Ashish Kumar Maurya. The objective of my paper is to understand and study the nature of heterogeneous medical data, and what are the classification of heterogeneous medical data and the challenges and application for the same. So in my presentation, I've included introduction part, literature review, medical data diversity, application of heterogeneous data, medical insight, conclusion, and references. As we all know, the data in today's time is generating at a humongous speed. Hence, in medical sector also, the data has been increasing at a very fast rate due to an advancement in patient care system, scientific research, and digital health technologies. These data are collected from variety of sources, including digital health records, medical imaging, smartwatches, and administrative healthcare data. The medical data is naturally diverse due to its diversity, which include organized, semi-structured, and informal format. The diverse nature of data cannot be analyzed using simple tools and method, making it difficult for decision maker to make conclusion based on the scattered data. So we use artificial intelligence and machine learning technologies for handling such complicated health information data. Right, we have data harmonization, which make this diverse data set from different sources more compatible and comparable. Standard framework like DICOM, which is digital imaging and communication in medicine, which help us to share and store images from medical sector. And we have HL7 FHIR, which is fast healthcare interoperability resources, which help us to share medical data from various communities of hospitals. I have reviewed 30 paper in my paper, and I have attached a table of all the 30 paper with the finding and research title and everything. Yeah. Now I have medical data diversity. Have here I have presented a head cube of heterogeneous data, which is a 3D model that help us to understand and categorize heterogeneous data in industry system. The first axis of the cube shows different data sources categories like structure, which tells how data is organized, if it is organized in a paragraph form or if it is organized in a table form. Next category is element representation, how data is presented, if it isn't presented in a text form or image form or whatever form it is our data is in. Then we have third category, that is information, that tells how much information it can hold. Then we have noise, that tells how clean or messy the data is. Then we have relevance, that tells how much data is important for our task, right? Then we have second axis, which tells which shows the type of heterogeneity in our data. First is terminology. Terminology tells different term used for the same concept. If I use certain term for a certain concept, you can use a different term for a same concept, which is terminology. Then we have syntactic, the different file format or data type. Then we have semantic, which means different meaning for the same thing. Like I use temperature meaning for the room temperature, you can use temp for engine temperature also, right? Then we have statistical, that is value varying from randomness to or different distribution. When then we have semantic, human interpretation can be different. I can interpret a certain thing a certain way. You can interpret a certain thing a certain way. Suppose I had interpreted red as warning, a certain someone can interpret red as stop. And then the third axis that represent a scale from homogeneous to heterogeneous data. It's just not black and white. Data can be more or less different. It helps us to understand and identify where and how data varies, and, and understand which type of difference exists between data sources, and plan better integration and machine learning strategies based on our data which is available to us. Now we can classify our heterogeneous data into three types. First is unstructured data, semi-structured data, and structured data. Firstly, unstructured data have no definite shape, form, or structure. The vast bulk of medical data include audio, video files, scribbled doctor's note, and medical imaging. The advanced AI technique, including models that uses deep learning, are needed to handle and analyze this information effectively. We have NLPs, natural language processing, that can be used to understand this type of data and use it wisely. Then we have semi-structured data. Semi-structured data is one that does not follow a rigorous format like structured data, but it does contain tags, marker, or metadata that provide some level of organization. It basically acts as a bridge bridge between structured and unstructured data, making it more adaptable and slightly easier to analyze. We can use normal tools such as NoSQL databases and data lakes and big data framework to assist and manage such semi-structured data. And lastly, we have structured data. Structured data is the one which is highly organized, kept in a certain format. We can use such as relational database. For example, we have patient demographics, test findings, and medicine prescription are the common examples of structured data. In structured data, the information is well organized and stored in a precise way. The information is arranged in a table which have rows and column. Searching is simple as we have SQL. We can use simple SQL queries to manage and analyze such structured data. Then we have applications of heterogeneous medical insight. Before talking about application, we have certain challenges also with medical data, like data quality. We can have inaccuracy in data, missing data we have scalability issues with the heterogeneous data in real time processing. We have standardization, terminology variation. We can have terminology variations also. We have data formation differences, data privacy issues, and data interoperability issues also with heterogeneous data. Now,
Ma'am,
coming to the
uh,
application part
ma'am,
of heterogeneous data, the use of AI
ma'am,
and machine learning in the development of different categories of medical
excuse me,
data
ma'am.
is rapidly growing. Consider the use of neural system techniques, for example, for health image dissipation, and discover
Ma'am,
significant development in disease documentation. We have AI empowered measurement that can use to spot a disease, and found that non-natural intelligent representation outperforms the dermatologist in the diagnosis of skin megalagnis from medical photos. Hospitals are also using cloud-based platform to join and include data from the devices and patient monitor tools, which help the healthcare provider to detect and trend in chronic condition in real real time. Deep mind AI model that have showed great promise in anthropology by correctly detecting more than 50
hello.
eye disease from 3D
Ma'am, are
retinal
you able to hear
scan,
me?
something which need a specialist to detect. Online supercomputer technology improvement in big data offer a vast amount of diverse health information. How real-time information dissipation is made imaginable by cloud strategies, which also shrink and the mandate for the local floppy space. Machine learning and AI procedures have validated interest in figuring out complex health information format, and furthermore computerizing an NLP method and can be used to evaluate unstructured health record and produce convenient information. Then we have future scope. In future, we can improving data interoperability. We have issues with the heterogeneous data, so we can use data interoperability, AI integration, data security, and ethical compliances, and standard like systematic nomenclature for medicine and in clinical terms, which is basically a dictionary that is used by the doctors and the hospital, which use same nomenclature for a particular disease. Like if somebody have a heart attack, there are certain code for it which is used by every doctor and hospital. Same nomenclature has been used. We have HL7 FHIR, that is fast healthcare interoperability resources that allows us to share medical data across the hospitals and communication channels, which makes seamless global health exchange of data. We have ontology-based method support better clinical decision and research. We have AI and machine learning, including deep and fused learning, are improving diagnostic accuracy while maintaining the patient privacy. We have also blockchain, that is increasingly used for secure and decentralized medical data management and fraud prevention through smart contract and regulatory framework are evolving to address privacy, ethics, and accountability in AI-driven healthcare. Additionally, AI is being applied to multihomeous data to advance precision medicine through personalized treatment and early disease prediction. Now, lastly, we have conclusion. For effective management of heterogeneous medical data, we need a unified approach combining standardized framework, advanced computational technique, and ethical consideration. Structured data is widely used, but unstructured data offer richer opportunities for AI-driven analytics. Standard like systematic nomenclature and fast interoperability are vital for interoperability but challenging to implement. Technology enabling scalable and secure data management includes deep learning, NLP, cloud computing, and machine learning. Important issues to address are privacy, ethical concernings, and legal compliance. Future areas which must be included are enhancing the data interoperability and ensuring data privacy and promoting ethical AI practices. That's all from my side. Here are the references here are total of
Hello,
27 references which I've used in my paper. That is all from my side. I'm open for any
hello.
question from your end.
Ma'am, am I audible?
Hello?
Hello.
Yes.
Ma'am, are you
Hello?
able to hear me?
Yes, yes, yes.
Hello.
Yes, yes, yes.
Okay. Ma'am, are you done with your presentation?
Yes, I'm done with my presentation.
Yeah, Sweta ma'am, I have only
Yes.
one question for you.
Yes.
Can you tell me what do you mean by forecasting and backcasting in futuristic?
Forecasting and
Backcasting.
forecasting and backcasting in which terms you were asking, ma'am? In medical data aspect or?
No, in general, I am asking in futuristics.
Okay, and backcasting.
Huh.
Ma'am, it basically forecasting is for predict and estimate something about future, and broadcasting means transmit a program or information to a wide audience, I feel, if it is in broader terms.
Okay, okay. Thank you. Yeah. Next,
Thank you, ma'am.
please. Next participant, please.
Yes, ma'am. Ma'am, just before starting the next presentation, I would just like to make a request to all the participants to please be prepared with your presentation within the time limit. We cannot extend the time limit because there are 10 presentations which had to be completed in a certain limit. So I request everyone to please respect the time constraint. Okay, so now let's just move on to the next presenter, which is Ritika J. Prabhu from Amrita Vishwa Vidyapeetham. And the paper title is Forecasting the Stock Prices of Green Energy Companies in India Using Machine Learning Models. Ma'am, you can start with your presentation.
Yes. Is the screen visible?
Yes, ma'am, your screen is visible. You can start.
Good evening, everyone. My name is Ritika Prabhu, and I will be presenting our paper on behalf of our co-authors. The world is slowly moving towards the sustainable solutions for everything, even energy. Subsequently, the renewable energy sector has grown significantly over the past year, with over 15 Indian renewable energy stocks jumping more than 100%. India, in particular, is at the forefront of this shift. The country has set ambitious goals to generate 50% of its electricity from non-fossil fuels by 2030 and achieve a net zero emissions by 2070. To reach this target, India prioritizes clean energy initiatives with aggressive plans. As a result, many companies are stepping up their efforts to contribute to a more sustainable planet, and several Indian companies are leading their way with green energy.
From this graph, it is visible that there is an increase in the stocks of the green energy companies with the growing focus on renewable energy. Investors predicting their stock prices accurately is important for making smart investment decisions. So in this study, we use machine learning models to forecast the stock prices and see which method works the best. Many researchers have used machine learning to predict stock prices. Some compared different algorithms, others looked at the high frequency data, but most studies focus on the broader sectors or global markets. And we also looked at, these are some of our references we have took from. And these are discussing the India's renewable energy policies and future potential of the sector. Coming to the research gap, although many studies exist, very few focus on specifically on Indian green energy sector. Also, most past studies only used 1 year data, which isn't enough to capture the long-term patterns. So we decided to use a 5 year data to improve the accuracy and capture seasonal and external effects. So our research questions are mainly focused on how accurately machine learning models predict the stock prices of the green energy companies in India and which model gives a more accurate forecast. Coming to research methodology, we used a descriptive approach and collected daily stock data from investing.com and BSC for the 5 years from December 2019 to November 2024. We focused on the three companies, KP Energy, BF Utilities, and SJVN. We used ARIMA, Random Forest, and support vector machine for prediction and evaluated them using the mean absolute error, mean squared error, root mean squared error, and R square. From ARIMA, we first PDF test, then we use the auto error metrics like the mean absolute error, mean squared error, and all. In case of support vector machine, we calculated daily returns for the returns and created a target variable, 1 for profit and 0 for loss. We used the support vector classifier with a linear kernel. We evaluated the predictions using accuracy score, classification result report, and also mean absolute error, mean square, and R square for checking how close the predictions were to actual values. In case of random forest, we used open, high, low prices and volume as input and price as output. We use 100 trees in our model. The model was trained and tested using the same evaluation metrics. These are the numerical values which we got after the analysis. And from this results, we applied all three models to all three selected companies. And from the metrics, we saw that ARIMA worked differently for each company, while support vector and random forest gave more consistent results. Random forest showed a better R squared value and low errors, meaning it was more accurate. Then coming to findings, from our analysis, we found that ARIMA had higher errors and inconsistent accuracy. Support vector machine performed better in terms of mean absolute error, and random forest had the best overall performance with high R square and low errors. Also, the KP Energy and BF Utility showed a strong upward trend in stock prices over the past 5 years. In conclusion, we can say that random forest was the best performing model for the stock forecasting stock prices of green energy companies, and it gave more accurate and reliable predictions. And also we observed a significant growth in the stock value of KP Energy and BF Utilities, reflecting a strong future for green energy in India. Thank you.
Yeah, did you applied multi-class classification using SVM in your project? Hello, am I audible?
Yes, ma'am. Yes, ma'am.
Ha.
About the analysis, my co-author would like to answer.
Yeah.
Am I audible?
Yes, sir. Yes, sir.
So for the SVM, we didn't use we have been just use the according to the basic SVM model has been used. We didn't use the multiple areas.
Okay. Okay. Yeah. Thank you, sir.
Okay.
Yeah.
Okay.
Thank you. Yeah.
Thank
Thank you.
Thank you, ma'am, for your presentation. Now we'll go on to the next presenter. So the next presenter is Chaitanya Raju from Amrita Vishwa Vidyapeetham, and the paper title is Integrated Object Detection and Scene Analysis for Waste Classification using YOLO and NLP Techniques. So you can start with your presentation now.
Yeah, can you hear me?
Yes, sir.
Mm. Can you see my screen?
Yes, sir.
Yeah, good evening everyone. Today I'll be presenting our paper Integrated Object Detection and Scene Analysis for Waste Classification using YOLO and NLP technique. Our paper ID is 161. Myself, I'm Chaitanya Raju, and my co-authors are Madhureshma, Anvesh, and Lekha S. Nair. We are from Amrita Vishwa Vidyapeetham. Yeah, so here's a brief overview of what we'll cover today. We'll start with an introduction to our work and followed by a motivating example. Then we'll dive into the problem statement and review related work in the field. And I'll present our proposed solution with a model architecture. After that, I'll share our experimental results, show some image and video outputs, and compare our models with existing models. And finally, I'll conclude with our findings and discuss our future work. So, introduction. Our core objective was to develop an intelligent waste classification system. We achieved this by integrating YOLO V8 for object detection and BLIP for scene understanding using NLP, aiming for accurate identification and categorization of waste types. This project utilizes a dual modality approach. We combine visual data such as images and videos with textual context derived from captions and synonyms from the blip. This combination significantly improves both classification accuracy and system's ability to comprehend the scene. The system is designed to be real-time and scalable, making it suitable for wide range of deployments, including urban, industrial, and environmental settings. Ultimately, our goal is to create a sustainable impact by supporting efficient waste sorting. So let's look at the motivating example. We are all familiar with the issue of urban overflow, where rising waste leads to overflowing bins and significant health issues. Our solution is an AI-powered classification system that combines object detection with NLP for smarter and more efficient waste sorting. This enables real-time sorting, automating waste categorization, and significantly reducing the manual effort required. It also this innovation contributes to a cleaner future by promoting sustainability and achieving cost savings through improved waste management. So problem statement, the current state of manual waste segregation is highly problematic. It's time consuming, error prone, and notably inefficient for large scale operations. Furthermore, existing deep learning models often lack contextual awareness and struggle significantly when faced with diverse environmental conditions. A critical limitation we identified is that most current systems do not leverage textual understanding to enhance object recognition accuracy. Therefore, there is a critical need for an automated, adaptive, and contextual aware and context aware waste classification system. So given the time constraint, and I'll just explain all the limitations of this previous works. The limitations in the existing models, particularly the lack of contextual awareness and real-time adaptability, which motivated our integrated approach. So I'll explain our solution approach with the help of architecture. So here you can see the two different pipelines. One is for the image and for the video. So when an input image first undergoes pre-processing, then it passes through the blip model where it will generate a caption of the explaining the scene of the image, which is crucial for scene understanding. Following this, we perform synonym extraction using NLP technique WordNet, and then caption analysis. So here we are trying to differentiate whether the image we have given is a waste environment or a good environment. So if a caption has a keywords related to like garbage, trash and all, we assume it as a waste environment, then we'll go into the YOLO V8 detection, or else it will be concluded as a clean environment. And then this image will be fed into the YOLO detection model, enhancing its ability to accurately identify and classify objects, leading to our final image output. And for the video pipeline, an input video stream undergoes frame processing where individual frames are extracted. These frames are then fed into YOLO V8 model or pre-trained model, so allowing for efficient and continuous object detection and classification in video, resulting in our video output. So we conducted extensive experiments to evaluate our model performance. The graph YOLO V8 model performance shows how our model's mean average precision. The blue line represents the accuracy at threshold 0.5, while the orange line indicates the performance across threshold 0.5 to 0.95. As you can see, the mean average precision generally increased with more epochs, indicating that the model continued to learn and improve. And in the table, we can see we achieved a precision of 73.3%, meaning that when our model identifies a waste item, it is correct about 73%, 73.3% of the time. Our recall stands at 23.6%, and mean average precision is 25.8 at threshold 0.5, and at threshold 0.5 to 0.95, it's 18.2. So here is the output for the image classification, and this is for the video. You can see for every frame it will detect, and it all be combined as a video again after dividing into frames. So when compared to our proposed integrated model achieves a precision of 73.3, recall of 23.6, and mean average precision of 25.8. So when compared to techniques like adaptive domestic waste segregation, which has a precision of 75%, our model is highly competitive. Similarly, the intelligent waste segregation technique shows 71.2% precision, and the waste collection and segregation model is at 72.5%. Notably, our mean average precision is strong and compatible to or even better than some existing methods. So while some models might excel in one specific metric, our integrated approach provides a robust and balanced performance across different evaluation criteria, especially given its unique dual modality and contextual understanding capabilities. So in conclusion, our model combining YOLO V8 and BLIP demonstrates strong precision and scalability. This offers a reliable solution for automated waste classification and significantly contributes to environmental sustainability efforts. Looking ahead, our future work focus mainly on key areas such as dataset expansion. This involves broadening dataset diversity to include various lighting conditions, environments, and new waste types. This will significantly improve our model's generalization and robustness. Secondly, we'll plan to focus on model and real-time optimization that includes further tuning of the model architecture and enhancing real-time performance to make it even more efficient for industrial and mobile applications. And we are trying to develop, we are trying to include developing a user interface and integrating our system with IoT systems for smart real-world waste monitoring and management. So these are all the references that were cited in our research, providing the foundation for our work. Thank you.
Yeah, good work. Can you tell me how this YOLO can be used to improve chatbot understanding?
Like general,
Yeah, using some object detections.
um, it can enhance chatbot to visually interpret and describe images or real world environments.
Mm-hmm.
For example, like a user can upload an image and
Mm-hmm.
YOLO detects objects in it. These detections can maybe converted to NLP descriptions,
Mm-hmm.
which the chatbot can process and respond.
Okay. Okay. Yeah. Sure. Thank you. Yeah.
Thank you.
Thank you, sir, for your presentation. Now we will go on to the next presenter. The next presenter is Jyotika Rohita from Sagi Ramakrishnam Raju Engineering College. And the paper title is Leveraging Artificial Intelligence for Detection and Filtering of Inappropriate Social Media Content. Ma'am, you can start with your presentation.
Okay. Is my screen visible?
Yes, ma'am.
Okay. Good evening, everyone. I'm Rohita from SRK Engineering College, and I'm here to present our project titled Leveraging Artificial Intelligence for Detection and Filtering of Inappropriate Social Media Content. In this section, we undergo these topics like introduction, project overview, system architecture, methodology, technical requirements and for features, results, conclusion and future scope, and the references. Coming to the introduction, nowadays social media platforms are facing more online threats, making it harder to keep the internet safe. So our project showcases an AI-powered system that can detect and filter out the inappropriate text and images. Deep learning models and NLP techniques are utilized by the system to detect the hate speech, toxic terminology such as slang, and the explicit imaginary while maintaining the document integrity. Also, by learning from large data sets, the system continuously improves its accuracy and minimizes the false positives and negatives. Coming to the overview of the project, the main purpose of my project is to build an AI-driven tool to automatically detect and filter inappropriate text and images in any formats. And key features of our model is multimodal filtering. That is, we can filter text and images at a time, and also preserves the document structure. We use BERT and ResNet advanced AI models to detect text and images, and also we generate the statistics of our filtered data. And also our project is scalable and cost effective, and it is a moderation system which reduces the manual work and improves the digital safety. Coming to the system architecture, we created an application or user interface using the Streamlit web interface, and user can upload any type of data, document, that is text or docx or PDF, and the document further goes to the content analysis, that is text processing pipeline and image processing pipeline. In text processing pipeline, the text of in the document is extracted and undergoes the dictionary-based filtering. And then it generates the statistics of the text. And coming to the image processing pipeline, the images are extracted from the document, and here we use two types of detection models, that is the transfer-based NSFW detection, that is not safe for work, and also we use ResNet 50 violence detection, and also we used HSV color analysis for detecting any blood or other types, and we also generate the statistics of the images. And output layer, that is a document filtered document is given, and it can be downloaded as we have a download service, and also displays the statistics of the filtered document. And coming to the methodology, we used dictionary-based filtering for the text analysis and NLP techniques. And for image analysis, we use the HSV color space analysis, and also two detection methods that we are already discussed. And the main theme is a document structure preservation methods. And coming to the system requirements, we use Python 3.8 to 3.11 capability and cross-platform. And our core features of our project is multi-format document that can support any type of document. Also, intelligent text filtering and image content analysis and statistic reporting. That is, statistics are generated accordingly. And coming to the results, the first image shows the interface of our project, which has where we can upload the documents, and also a content that shows about what is our project and what gives overview of it. And figure 2 shows that a document that contains text and images of both appropriate and inappropriate content. This document is uploaded in the in our project, and then the output is filtered, gives the filtered document, which can be downloaded as we have the download service. And it also shows the statistics of both text and images. That is, test statistics says that our document have 5 flagged inappropriate words out of 21 words, and also shows the clean ratio of it, as well as the coming to the image statistic, it is the same. And for figure 4 tells about the filtered document that will be printed. And coming to the conclusion, our project is a has multi-format support and uses advanced AI models, and also efficient and scalable. And for future scope, we are thinking of having the multilingual support, and also video content moderation, adaptive learning. These are the references we have used in our project. And thank you.
Yeah. Can you list out some machine learning algorithms which are suitable for classifying social media contents?
Machine learning, we can use TF-IDF. But in our project, we use BERT, that is bidirectional encoder representation, because it is powerful enough to understand the context in which the word is used compared to the TF-IDF.
Okay, thank you. Yeah.
Thank you, ma'am. Thank you for your presentation. Now we will go on to the next presenter. So the next presentation will be done by Shahida Dinisa Sheikh from Dayanand Sagar College of Engineering. Any of the authors or co-authors of this paper are present in the meeting, then please give me a response. If not, then we will have to stop with the session, because all the participants are done. Then we can proceed to the closing remarks. Okay. I think this participant is absent. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for everyone. We, on behalf of the whole team, thank you for the support during 10th version and all the previous 8 versions of the conference. We will be happy to see you in the 11th version in 2026. All the presenters would be getting their digital certificates via email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD. Lastly, I also thank our session chair, Dr. Vidya Gaikwad, for chairing this session. A token of appreciation to the chair on behalf of Team ICT4SD and Global Knowledge Research Foundation and partners. Thank you so much, ma'am, for your valuable presence.
Yeah, thank you. Thanks a lot.
Now, before ending this session, I request everyone to please turn on your camera so that I can take a quick snapshot. Okay, I've taken the snapshot. Now everyone can leave the session. Thank you.
Yeah, thank you. Thank you.